Breakthrough. Sombrero Galaxy's halo suggests a turbulent past. I'm Steve Belair. Welcome to Breakthroughs. Hubble indicates the stately Sombrero underwent major mergers. Like a desperado in the Wild West, the broad brim of the Sombrero Galaxy's disk may conceal a turbulent past. The Sombrero M104 has never been a galaxy to fit the mold. It has an intriguing mix of shapes found in disc-shaped spiral galaxies, as well as the football-shaped elliptical galaxies. The story of its structure becomes stranger with new evidence from the Hubble Space Telescope, indicating the Sombrero is the result of major galaxy mergers, though its smooth disk shows no sign of recent disruption. The galaxy's faint halo offers forensic clues. It's littered with innumerable stars that are rich in heavier elements called metals, because they are later generation stars. Such stars are usually only found in a galaxy's disk. They may have been tossed into a halo through mergers with mature, metal-rich galaxies in the distant past. The iconic galaxy now looks a bit more settled in its later years. It is now so isolated there is nothing else around it to feed on. This finding offers a new twist on how galaxies assemble themselves in our compulsive universe. Hubble's sharpness and sensitivity resolves tens of thousands of individual stars in the Sombrero's vast, extended halo, the region beyond a galaxy's central portion, typically made of older stars. These latest observations of the Sombrero are turning conventional theory on its head, showing only a tiny fraction of the older metal-poor stars in the halo, plus an unexpected abundance of metal-rich stars typically found only in the galaxy's disk and the central bulge. Past major galaxy mergers are a possible explanation, though the stately Sombrero shows none of the messy evidence of a recent merger of massive galaxies. The Sombrero has always been a bit of a weird galaxy, which is what makes it so interesting, said Paul Goodfriel of the Space Telescope Science Institute, Baltimore, Maryland. Hubble's metallurgy measurements, i.e. the abundance of heavy elements in the stars, are another indication that the Sombrero has a lot to teach us about galaxy assembly and evolution. Hubble's observation of the Sombrero's halo are turning our generally accepted understanding of galaxy makeup and metallicity on its head, added co-investigator Roger Cohen. Long a favorite of astronomers and amateur sky watchers alike for its bright beauty and curious structure, the Sombrero galaxy now has a new chapter in its strange story. An extended halo of metal-rich stars with barely a sign of the expected metal-poor stars that have been observed in the halos of other galaxies. Researchers puzzling over the data from Hubble turned to sophisticated computer models to suggest explanations for the perplexing inversion of conventional galaxy theory. Those results suggest the equally surprising possibility of major mergers in the galaxy's past, though the Sombrero's majestic structure bears no evidence of recent disruption. The unusual findings and possible explanations are published in the Astronomical Journal. The absence of metal-poor stars is a big surprise, and the abundance of metal-rich stars added to the mystery. In a galaxy's halo, astronomers expect to find earlier generations of stars with less heavy elements called metals, as compared to the crowded stellar cities in the main disk of a galaxy. Elements are created through the stellar life cycle process, and the longer a galaxy has had stars going through this cycle, the more element-rich the gas and the higher metallicity the stars that form from the gas. These younger, higher metallicity stars are typically found in the main disk of the galaxy where the stellar population is denser, or so goes the conventional wisdom. Complicating the facts is the presence of many old metal-poor globular clusters of stars. These older, metal-poor stars are expected to eventually move out of their clusters and become part of the general stellar halo. But that process seems to be inefficient in the Sombrero galaxy. The team compared the results with recent computer simulations to see what could have been the origin of such unexpected metallicity measurements in the galaxy's halo. The results also defied expectations, indicating that the unperturbed Sombrero had undergone major accretion or major events. The results for the Sombrero are surprising because its smooth disk show no signs of disruption. By comparison, numerous interacting galaxies like the iconic antennae galaxies get their name from the distorted appearance of their spiral arms due to the tidal forces of their interaction. Mergers of similar massive galaxies typically coalesce into large, smooth elliptical galaxies of extended halos, a process that takes billions of years. But the Sombrero has never quite fit the traditional definition of either spiral or elliptical galaxy. It is somewhere in between the hybrid. Wow. Crazy. I'll leave a link in the description to the full article, and as usual, please like, share, subscribe, and take care.